so I don't forget. Right. So, like I said, welcome to everyone. Yeah, today's session is going to be on LinkedLists. This is like one of like the so many sessions we've been having. The whole point of this session is to kind of just touch on algorithm, data structures, solve questions around them, just to make sure you are kind of getting comfortable enough to be able to understand what this data structures and algorithms are, because they're actually important in day-to-day life, even though I know that interview sometimes can be overstretching, but it's actually important to understand this in day-to-day life. And then, when you're preparing for interviews, what to expect or how to work with these things, how to kind of what you need to understand to be able to say, okay, I'm comfortable enough to be able to go for an interview and work with these problems, right? So that's why we've been doing these sessions. And if you see my screen, we have this GitHub repository that we've been using to keep track of the sessions, because we know, like we have right now, we would always have first-time people that joined along the way, or people that even join after this whole thing is over. So we have this repository to keep track of this so that you can even use it later on for, okay, I just want to refresh my mind. I have an interview coming up and I just want to check, let me check the boxes and see where I'm at. And what gaps do I need to fill? So that's why we created this repository. So like I said, we started a long time ago. Not so long, like kind of around March, but that's long, So, and then we've had some sessions. Most times it has been like maybe once every month. We've talked about strings, arrays, we talked about time complexity, we talked about stacks, queues, and the last one we had was recursion. Bear in mind, these sessions are not full course session. They are not like it's not an Udacity or Udemy or Coursera course on LinkedLists. No, there's no time for that. So it's just like a crash course if you don't have any idea about what this, data structures are like. You don't have any idea about what LinkedLists are. Today's course is more or less like a crash course. Like we spend like first 40-30 minutes to kind of give you an overview of what data structure is about. And if you know what the data structure is about before, it's more like a refresher course for you, right? And then we're going to share resources on if you want to read more, if you want to understand more about it. And the most important and fun part is that we get to go into breakout rooms where you solve questions on linked lists with other people in that breakout room. And yeah, it's always fun. When we get there, I'm going to tell you what you need to do. So without wasting so much time, I'm going to share this repository on the chat so that you can check it during your own time and just get where you are at. But I hope everybody here, or most people here, kind of have an understanding of what recursion is, because it's kind of going to help you to understand what today's session is about. And without wasting so much time, we're going to spend the next 30 minutes trying to do the refresher or crash course on LinkedLists. And we'll be having an amazing somebody give us that session. And then, yeah, I'm not going to waste so much time. So, hi, Joda. You ready? Hey, Joda.
Hey, I'm ready.
Okay, so I'm going to stop sharing my screen now and you can start.
All right. Quick question before you go. What's the time that we're looking at here? For like how long
we're gonna. So you should be done in the next 40 minutes.
40. Okay. Interesting.
Max.
All right. Cool.
You'll be fine.
Yeah. Stop sharing. I can't share what I'm sharing.
All right.
Okay. So, hey everyone. By way of introduction, my name is Opemipo Joda, as you can see on the screen. I'm a software engineer or a dev at Palantir Technologies. Not many people know what that is, but it's a tech firm here in the UK. And Hope, being my very dear friend, has co-opted me into giving a lecture on linked lists today. So I will try to talk through the the main things which I believe should be, what is a linked list? How do you think about a linked list? How does a linked list vary from, arrays that you might know? I think I heard earlier on that today is someone's first time. So I will try to have like some background information, but really there's some background reading you might need to do on things like recursion, as Hope has mentioned. And also then obviously the whole reason we're here, how to think about solving problems with linked lists. So for starters, what was a linked list? I hope people can see this screen.
Yeah, we can see.
All right, cool. So the linked list basically is, where is this down? Don't behave like this. A linked list is basically a type of data structure, linear data structure. When I say linear data structure, I mean it's a data structure that arranges, forgive my handwriting, that arranges data like, from one point to another. We have a first, a second, a third, a fourth, and on and on, much like an array. The difference between a linked list and an array is that your arrays, for those of you that might know, your arrays are stored in a contiguous block of memory. What does that mean? If I have an array in memory, and let's say the first element in the array, this one, was stored in position 55. This is an arbitrary number I'm giving, but this will mean that the second element will be in position 56, the third element will be in position 57, and on and on. And the advantage that this gives you in an array, by the way, the advantage that this gives you in an array is that from the first location, you can tell where the 10th location is, for example. So if I tell you that my array is stored in location 55, give me the 10th element of this array. I know that it's going to be 55 plus 10. That's 65. You know that information immediately, right? Because all the data in that array is stored right next to each other in memory. And this has its advantages and it has its disadvantages. One classic disadvantage of an array is the fact that when you want to insert or delete, you're going to have to move everything. What do I mean by that? So you see this array I have here. Let's say I have 5, 3, 2, 1, 8, 7 inside. Random numbers, doesn't matter. But I want to insert 0 in between 2 and 1. How will I do this in an array? I'm going to have to delete 1, 8, and 7, move all of them one step to the right, 1, 8, 7, then put my 0 inside. That's the only way I can insert in an array, because they always have to be stored next to each other. So that means if you put something in the middle, everybody else that was to the right has to be moved one step down. And that would be the same if I want to insert 5 things, everything has to be moved 5 steps down. And that's a very expensive operation. Imagine if this array was of size 1,000, right? That means that I would have to move 1,000 things just because I want to insert one element. And that would be the same for delete. Imagine I wanted to delete 0. What would I do? Naturally, you know that I would have to not only just remove 0, but I can't leave it like that, because remember, your array needs to be contiguous. Everything needs to follow each other. That means I have to delete all of these other guys as well and shift them one space to the left. Again, this is an O of N operation. Those of you that have done the time complexity class will know what that means. This just basically means that on the worst case scenario, I will have to move every element in the array. Imagine if I wanted to insert at the beginning, I would have to move all N elements in the array. So this is an O of N operation, inserting and deleting in an array. That's where a linked list comes in. Why is a linked list better? Before I say that, let me explain how a linked list works. So the way linked lists work is they are not necessarily stored next to each other in memory. They are stored anyhow. So you have your element, this same elements now. I would have my element 5. I would have my element 3. I'll have my element 2, element 1, 8, and 7. These are all stored wherever in memory. Doesn't really matter. What matters is that each element will contain a pointer or an index to where the next element is stored. So 5 will not only contain the value 5, but it will also contain some information about where 3 is stored. So it's basically pointing to 3. So from 5, I can not only read the current value, but I can also say, oh, what's the next value? Then 5 will tell me, yeah, the next value is stored in this location. Then I go there and I see 3. And when I go to 3, 3 will also have the next value. You go there, you see 2. 2 will also have the next value. So a linked list will end up being stored. Obviously, this is a very bad way to visualize it, but if I visualize in a bit better way, you end up having separate nodes. It's very important to note that they are separate, but they all have pointers to one another. So 5 points to 3, 3 points to 2, 2 points to 1, and on and on and on. Why did we do this? Well, remember the problem we had with arrays, the insertion and deleting problem. Imagine if I wanted to insert 0. Same thing I did in this array, but I want to do it now on my linked list. How would that work? Well, all I would need to do is create a new node called 0, right? And where do I want to insert 0? Between 2 and 1. Well, all I just need to do is tell 2, instead of pointing to 1, tell 2 to point to 0. And 0 to point back to 1. And I've successfully inserted 0 between 2 and 1, and 8, 7, and all the other maybe 1,000 elements here don't care. I don't have to do anything to everybody else. Whereas in the array, I'll have had to move every other value. Here, all you really care about is the elements that you are inserting before. As long as I know where I want to insert it, it's an O of 1, it's a constant time operation, it's O of 1 operation. It's just one thing I'm doing. I'm just saying 2 points to me, and I'll point to 1, and that's it. Insertion complete. Significantly faster than if I was using an array. Same thing with deleting. I want to delete 0. Okay, well, just tell me, who is pointing to 0? 2. Who is 0 pointing to 1? Okay, just take that pointer from 2 and point it to 1 directly. And now, just like that, 0 is deleted from this linked list. So yeah, to summarize everything I've said so far, the main reason we have a linked list data structure is a linear data structure just like an array, but it significantly improves insertion and deletion time, because when you have things linked in this way and they don't have to be stored next to each other, we just need to change the pointers a little bit to insert, and we don't have to do an O of n operation. Now it's a constant time operation. All right, so before I move on to types of linked lists, any questions? I'll give 10 seconds. If no questions, I'll continue. All right, cool. So types of linked lists. There's two main types of linked lists. We have single linked lists and doubly linked lists. Single, and double linked lists. And the difference is just that how many pointers do they have? So this example I gave you is a single linked list where we have element 1 points to element 2, which points to element 3, and so on and so forth. And there's no backward pointer. On a double linked list, we have element 1 pointing to 2, is saying that, oh, my next guy is 2. But not only that, 2 also has a backwards pointer that is also saying, oh, the previous guy before me is 1. And so on and so forth. 2 can have the next element, maybe be 5. 5 knows that its previous element is 2. And 5 could know that its next element is 7. 7 could know its previous element is 5. Those are the two main types of linked lists that we have. How would this look like in code? This will, is there any way I can move this to like the next page or something? I don't think so. So the way this will look like in a code, if I was to write a single linked list, I'll have a class that looks like this. Maybe call it a node. Give me a quick sec, sorry for the delay. Right, so let's say we call it a node. And this node class will have, what will it have? It has a value, obviously, because there's a value inside this, my node, right? You can think of it like, oh, this guy that has 5 and is pointing somewhere. It has a value, which will probably be a number for the sake of this illustration. It will have a next pointer, which will be another node on the linked list. And in the case of a doubly linked list, it will have a previous pointer, which will be another node. And this is your node class, your linked list node class, right? So it may become apparent that the linked list itself is not like an object. There is no linked list. The linked list is just what we call this list of nodes that are all pointed to each other, right? Yeah, so here's how you would have your node class if you were to implement this in a class. So unlike your arrays, unfortunately, this is usually not a first class thing that your programming language will have. You don't have to implement an array yourself. It's implemented by Python, Java, any language you're using. Whereas if you were to be solving a question using a node, you'll most likely need to create your node class. Sometimes you don't, but sometimes you will. Okay, so I hope that much is clear. I would like some kind of acknowledgements that are making sense before moving forward. And if you have any questions, let me know. Is that clear?
Yeah, it's clear for me, Joda. Thank you.
All right. Okay. I'm seeing people in the comments saying it's clear. Awesome. All right. Very cool. So the next thing we're going to want to talk about is, so we've talked about the advantage of a linked list, right? Obviously, you should be able to tell that, yeah, linked lists are very powerful when it comes to inserting and deleting very fast, instantly. What about searching? So we've established that, let me clear this. We established that when it comes to inserting, you know what I'm just going to do? I'm just going to keep writing on the side of the screen. When it comes to inserting, it's constant time. I hope people know what this notation means. O of 1 basically means it's a constant time operation, happens instantly. It's not O of n. When it comes to deleting, same thing. Another operation you can have on a linked list is searching. So let's say I have a linked list and I want to search for, if there's a number 5 in this linked list. I want to search for the first value greater than 10 in this linked list. How would that work? Well, remember what your linked list looks like. Visually, it looks something like this. Say 7 pointing to 9 pointing to 6 pointing to 3 pointing to 8, right? And what you most likely have access to on this linked list is just the first element. So you have the first node. This is all that you have access to. How do you search, quote unquote, for, say I told you, oh, get me the first value less than 4. Okay, I need to traverse this linked list. How can I traverse this linked list? In the case of an array, for those of you that know and remember, in an array, traversing is very simple. Because everything is next to each other, I just iterate over the indexes. I know that this is index 0, 1, 2, 3, 4, 5, 6, right? So I'll just iterate and say, oh, get me the guy at index 0. Is that what I'm looking for? No. Get me the guy at index 1, index 2, index 3. I just keep iterating from 0 to n until I find what I'm looking for. That's how you traverse on an array. How you traverse on a linked list is a little different. The way you traverse on a linked list is you have the node you're starting with, and instead of just iterating that, oh, give me the guy at index 1, there is no index 1. We don't have any guy at index 1. What we have is the next value. So what you're going to do is you start from the node you're on, and then you go to the next value. So you move your pointer to this guy, then this is the person you're operating on. Then you go to the next value as well, and you go to the next value as well. So as you can see, it's very similar to array in terms of complexity. Searching will still be O of n. Searching and traversing will still be O of n. But it's very important to know that the way you do it is very different. So that's what I want to spend a bit of time talking on now, is how do we traverse over a linked list? Code-wise, there's two ways you can do it. You can do it iteratively and you can do it recursively. Now, Hope told me that this class, or hopefully most of the people in this class, have done recursion, so they know how to write recursive functions. So I'm going to go for the recursive approach, just because it's easier to think about. The iterative approach is not very intuitive. You can learn it yourself. It's important to know that there are two ways, but I'm not going to spend time teaching the iterative approach today. So how would I recursively iterate over this node? Well, what I would do is, like I've mentioned, I will start with the node I have. So say I give you a question, and the question says print all elements in the linked list. Well, what's the linked list? Let me give you a random one. 5 to 7 to 8 to 3. How can I print all elements in this linked list? Well, what does the function give me? Let's say print list is a function and it takes in a node. Now remember, your node looks like this. It looks like node. Your node class has a value. It has a next. For a single linked list, let's just do this. Has a value and has a next value. So how do I traverse over this? Well, it's simple. You start with the node you have, n. I say, oh, they told me to print everything. Let me print the current value I have. So I say print n dot value. Remember, there's a value field on this node, which is 5 in this case. So this will print out 5. Then the next thing I'll do is I will recurse, which is I will call this function again, but I'll call this function this time, it should operate on the next node. So I'll say this same function, this same print list function, print list, I'll call it on n.next. So now notice how print list takes in a node. So that's fine because n.next is a node. Remember, this will be a node and this will be like an integer. So this print list function, this entire function that we have here, will run again, except this time the node that is taking in will be this node here, node 7, right? That will now, because that was 5, the node 5.next will give me the node 7. So now node 7 will be the value that's passed into the function. So when we print end of value for that time, we will get 7 printed out. All right. And then that will call the function again on n.next or 7.next, which will give us what? Which will be the node 8. This will be the node that's passed into the function again. It will run the same function again. So you can see how just writing 2 lines, because it's recursive, it's going to happen again for the entire linked list. It's going to print out 8. It's going to call the function again for the next node. That one is going to print out 3. And obviously 3.next will throw an error. So you're going to have somewhere in the code that you say if n.next is equal to null, then just stop or something like that. Or you only print it if n.next is not equal to null, because once you get to the end of the linked list, the .next value will be empty or it will be null. Yeah, hope that's clear. Any questions? Seconds. Anyone has a question?
Excuse me. Can you go back to the if n.next equal to none? Can you explain what this is?
Okay, let me. Yeah, that's a good one. I'm sure I didn't explain it very clearly. So what I was trying to say there is that by the time you get to the end of the linked list, so say this was the last value in the linked list, it's .next, right? Will give you the next node, which is maybe 3, right? But 3's .next will point, it won't point to anything. It will point to null. Null is basically empty in programming science, if you know that. So when I call this n.next, the value that will be passed into the node for the next function will actually be null. So really what my function should look like is print list that takes in a node, n, and the first thing I should do is I should say if n is not equal to null, right? That is when I do all of this. That's when I do prints, and that's when I call recursively print list on the n.next. Because now I know that there's a value there. So when there is no value, n will be null, and this if statement will not run. So it will just not do anything, and the function will stop. So basically, that's like my for if you did the recursive class, you will know that there always has to be a base case. Because if a function keeps calling itself and it doesn't have a time where it stops, it will call itself forever, and that will break the program. You have Stack Overflow error. So you need to always have a base case. You need to have a case where the recursion should stop calling itself. And here my case is that when it is null, it will not execute this part, so it won't call itself again, essentially. If that makes sense.
Yes, it does. Sorry if I'm asking so much questions. What language are you using to write this?
This is 100% pseudocode. This is not an actual language. The reason I'm doing it this way is just to get you the idea of it. I've tried to be language agnostic. So if you're trying to write, I guess it looks most like Python, but I'm using curly braces, so it's weird. But it's just the idea I want you to get. Any language you're using will have null. Any language you're using will have if statements and will have functions. So it's just the ideas that really matter. But this is not an actual language. I'm sorry if that's confusing. I'm sorry. Okay, any other questions? Cool. What's next? Inserting, searching, removing, traversing. We've done all of that. All right, how to think of linked lists. Okay, so there's really nothing to write here. I just wanted to give a quick way to know how to think of, like, when you see a question, how do I know I'm supposed to use linked list in this question? And really the keywords are the things I've mentioned. One, it's a linear data structure. So when you have information that is arranged in a linear way, i.e. there is something, then a next something, then a next something, on and on and on. It is not arranged like a tree or a graph. It's not like, oh, we have one element that could have two possible next values. That looks more like a tree or a graph because it spreads out a bit. Just so you know what I'm referencing, your nodes will look something like this in a tree, or your nodes will look something like this in a graph, right? Things are pointing to each other anyhow. This is not linear. When it's linear, it is always straightforward, meaning there's always something before something, then before something else. When your question can be reduced somehow into that way, one example I can give is to say, oh, we have a house that are arranged on a street, from left to right, and you want to visit every element in that house, one after the other. So now you have data that is arranged linearly. Something always comes before the next, which always comes before the next. That's when you're thinking linear data structures. But remember, you also have arrays, and arrays are also linear data structures. So the next thing to know is if you are doing any insertions or deletions, then you most likely want a linked list over an array. For the reasons I've mentioned before, your linked list is just much faster and much better in those cases. Whereas with your array, you perform those same operations in O of n time. The other thing to think about will be, and this would be against using a linked list, will be, do I have like definite positions? Like, do they have anything like in the example I gave where they say they have houses on the street and you want to go to the fifth house? That means you want to go somewhere directly. That's the area that linked list doesn't shine. Array shines in that area. Because remember, if I have the starting index, I can just go straight to index 5 in an array. I can never go straight to index 5 on a linked list. I'll have to ask the first guy to give me 1, that one will give me 2, that one will give me 3, that one will give me 4 before I get to 5. So it's always better to use an array if I'm ever going to be doing direct lookup at indexes. But it's always better to use a linked list if I'm going to be performing any manipulations like insertions or deletions. when it comes to traversing and searching on arrays and linked lists, they are usually similar. Yeah, I believe that is most of what I wanted to talk about. I'm not sure I've used up 45 minutes, so let me use the rest of my time to answer any questions that you might have. And if no one has any questions, I guess we can just jump into the breakout rooms. Hope, what do you think?
Yes. I think we can. Yeah. Jump to breakout rooms. That'll provide more time to be able to solve more questions. So,
But let me give them like 30
does
seconds because people
anyone
might
have
still
any
be.
question, any concerns, anything at all? Even if it is what type of interview questions will require you to do linked lists, that's a valid question. Okay. Okay, I'm gonna assume nobody has any questions. So
Yeah,
probably
sounds like,
everybody understands what linked lists are. Maybe.
yeah, everyone here is too smart. Linked list is too straightforward. I like it. Yeah, I'm seeing in the chat people are saying no questions. So
Right then. So yeah, we can head to the breakout room then. So for breakout rooms, if you are new, what we literally just used to do is you get to choose what room you want to join. So we have intermediate, we have beginner room. It doesn't mean like you have to be an absolute beginner to join. It just means what are you comfortable solving today, or what is your appetite looking for today? That's just it. So for beginner rooms, you get to solve like easy questions, LinkedIn, linked lists, sorry, and all. And then for intermediate rooms, you get to solve like medium, sometimes hard questions on linked list. Yeah, that's what we usually do. So I have the breakout rooms right now opened. You get to choose your room because again, it's your call. It's what you decide, what you feel you're comfortable with. So we have 2 breakout room for beginners, and then we have 1 breakout room for intermediate. So just like I said, the difference is the questions we are going to be solving is in each room. So if you are like, if you are comfortable with easy questions alone, you can choose between any of the breakout rooms. And then, yeah, I've opened all rooms now, I guess. Yeah. So, and if you feel like, yeah, you want to task your brain a little, you can go into the intermediate room. You have facilitators in each room. They are going to be guiding you as to, coming up with a solution for the question. My ask for everyone is, sorry, before you jump to your rooms, please, this was the main room, right? So it was fine if you were muted, if you were like, yeah, I'm listening, I'm following, but like in breakout rooms, we need you to like open up, unmute yourself. If you feel like you want to turn on your camera, it's fine, depending on your bandwidth, but unmute yourself, that's important because you're learning from each other. The facilitator is not going to be in the room and teaching. We are not doing that. The person is just there and just trying to guide everybody into understanding the question and coming up with a solution. So you need to bring out your very best self, and you need to be willing to share your opinions. You need to talk. Don't feel any shy, or don't feel like, what if I don't know the answer? No, everybody's here to learn. And you can only learn from someone if they open up, right? And they can only learn from you if you open up. So if everybody decides to like just go mute, then we are not learning from each other here. So please, bring your best self. Be free to just say whatever it is in your mind. When you get to the rooms, they're going to tell you the question you're going to be solving. They're going to tell you how you're going to like solve it and all that. I think you get to use like code share and all that. So if you're not with your laptop yet, feel free to grab your laptop because you are literally going to be coding. And with that said, you can jump to the breakout rooms now. I've opened up the rooms. If you have any trouble joining any room, you can just tell me what room you want to go into and I will move you there. And for those that will be listening to the recording later, I'm sorry, this is the point where we pause our recording. And like I used to say, we don't record breakout rooms just to allow for that liberty for everyone to say whatever they want to say. So if you want to join the breakout rooms, come to the next meetup. That's all I can tell you. So welcome back. Is this everyone? Okay, yeah, I think so. Everyone is back. So welcome back. I hope you enjoyed the session. Like I said, so I don't know where the next session is going to be, but I don't know how comfortable everybody is right now. But the plan is for the next session, we're planning to do like a coding challenge. It's going to be like a multiple day coding challenge. We share the link to everyone, and then we can probably leave the link for 3 days or maybe the entire week, depending on. And you are meant to submit your solution. So the way a current coding challenge works is actually going to be very easy when we send the link. You just find a time that works for you, but make sure that whatever time you find, you solve the question like at a stretch or something. You can always come back to it, it's totally fine, but it's just always more helpful if you can say, oh, I'm blocking 2 hours right now to focus on this coding challenge and just solve these questions at a stretch. It's not going to be very difficult. It's not going to be like coding challenge. It's just a way for you to, kind of practice and put yourself in that mind zone or that mindset of, I'm going to do this someday. I'm going to have an interview someday and I have to solve this question. So we'll split it into like maybe easy, intermediate, and like maybe hard or something, just to ensure that you can always find something that would work for your competency level. So yeah, that's going to be the next one. We'll send the link out, and then probably the Saturday after that week, we can have like a meetup session where we discuss the solutions around it, and you just tell us what your experience was like, if you had any trouble with any of them, and yeah, so that's the plan for the next session. Any question?
Before we go into questions, could you maybe talk about like the Slack channel and things, because there's some new people here that might want to get connected.
Oh, true. Thanks for bringing that up. So we have a Slack channel where you can ask your questions. Even though there's rarely any question there, but you can always ask your question. People would always answer it. At least I would answer, maybe after 1 week, I don't know, but I would definitely answer. So I'm gonna share the link to the Slack. So we have the Slack workspace. When you join the Slack workspace, there is a channel called Algorithm and Data Structures channel. So please do join the channel and ask your questions, ask anything, you have any issues, just feel free to ask. Someone would always help you and respond. And we also have this, I was editing this, sorry, let me share the link. So we also have this GitHub repository. We used to keep track of the series. So for those that are just joining and you've missed or you just feel like you want to catch up on the things, Sherry, I'll get back to your question. So I feel like you want to just catch up on the things we've done so far. So we have, let me just quickly share my screen for a second. So we have this repository, and then you can just come here. You can just start from, the getting started session. This was where we started the whole series, and we just talked about time and space complexity and all that. And then we have other sessions on strings and array. These are the list of sessions we've done so far. So you can just use it to refresh your brain, refresh your mind on what these concepts are. And then most importantly is submitting your solutions. We encourage you to share. So for each of these, right, we have practice problems for you to be able to understand the concept more. Like if you're looking at stacks and queue right now, we have practice problem based on competency level for you to be able to understand it more. And then we encourage you to share your solution, your practice solution here. So you can fork the repo and just add your practice solution to each of the concepts you are focusing on that time, and then send us a PR. So you will see that many people already shared like their solutions, and the all way to contribute to it is kind of explained there. Like really simple, really simple. You see a lot of people that have already added their solutions already, and you see how they did it. So it's just you solve a question, you solve it on LeetCode, and you say, oh, I got the answer, and I just want to contribute my solution here. It kind of even puts you in check.
Oh, they said your font size is small. Can you?
Oh, okay. Sorry. Sorry.
Perfect.
So what I was saying is, so this is like the list of each of the sessions we've done so far. And you can just go to each of the links, and we sometimes put just like a quick overview, just to, if you don't want to go into the resources and you just want to brush up. And then we had resources to be able to learn more about each of the concepts. And there are practice questions that you can use to understand it more. So I was saying that if you solve any of these practice questions, most of them are LeetCode problems. So when you solve them on LeetCode, you get that, accepted mark, right? And you just feel like you want to contribute your solution to this place. To kind of keep yourself accountable, right? You can do it as, I want to do this every week, solve one question every week, and you need to send a PR of your solution. So it's just simple as like, I fork the repository. You can see PRs that people sent already. You fork the repository. You just look for the particular. Okay, I've not checked this. So you just look for the particular concept you want to focus on, pick the practice solution, and pick the practice questions, and then you add your solution to that folder. And then send your PR. So if you have any issues, just reach out to us on Slack. I will tell you how to do it. So that's it. So I'm going to send this link here. Please use it to check up or catch up on any session you feel like you've missed in the past. So, or you feel like you just want to check again, especially on recursions, those ones are like really important. And today's session will have it too also. So yeah, those are the resources we have to kind of just manage this series so far. And like I said, next session is going to be we doing a coding challenge, algorithm, kind of coding challenge, just some questions around what we've been discussing, what we've been talking about, like so far and all that. So yeah. Any other question?
I wanted to add something because we weren't able to finish the second problem. But I think it's like a really good problem to try out, especially because it's both helps your design skills and your problem solving skills. So I think that's the LRU cache one. So I would urge like people that were in the intermediary session to like really try to solve that question, at least attempt it. So before you go through the solution, just attempt it. And you can send me, I'll be on Slack. I think I've just found this thing. I can, in fact, I can create a LRU cache channel, a temporary channel, just so that people can post their problems on that channel, and I can, we can discuss about it over chat, and then maybe I can post the solution, and I can like send a VN or a write-up or something, I don't know, just to discuss how the solution works essentially. So, but really try out that problem, the LRU cache. I think it's a really good one, and see how it goes. Yeah. Can I create a channel?
Yes, I think you can.
Okay, I'll try it. So, and let's.
If you can't, just let me know. Yeah. So, Sherry, to answer your question, yeah, when you join the Slack workspace, there is a channel called Algorithm and Data Structures channel. So if you search for it, you just said you can join. Yeah. So, and with that, that's all we have for today. Thanks again for joining. Yeah, we did another one. Thanks, and we hope to see you again in the next session. Hopefully we see you back, see your face again. Thanks for our recurring, participants. We'll see you. So yeah, that's all we have.
Thank you so much, guys, and thank you, Hope and Deji, for everything and for the session. Yeah.